Right, hurrah. I think we're off. We've got about 20 minutes. We'll try and go quickly. Obviously, a lot to get through tonight. And thank you so much for the warm welcome. It's great to be here. Hello, guys, gals, non-binary pals, old friends, new friends. I used to work here, so it really feels like coming home for me. As Colin said, we're here from StreamNative. We're going to be talking about Apache Pulsar. Just to introduce ourselves first, you'll see I'm joined by Tim, who's over in the States right now. Couldn't be here in person. But Tim, do you want to introduce yourself?
Sure. I'm the developer advocate at StreamNative. I cover what I call the flippin' stack, Apache Flink, Apache Pulsar, NiFi, different ways of using different open source and streaming technologies together, trying to give people some help there.
And I'm John. So my background is with startups, scale-ups, different technology stacks, originally in telecoms, digital media, and then cloud enterprise software solutions. Been working there for about 25 years. So I said used to be at Scott Logic. I'm now at the company StreamNative, and my role is sales. So I'm growing our organization across Europe, Middle East, and Africa. So really pleased to be here to talk with you today. So we thought we would give a general overview of some of the concepts behind Apache Pulsar. We realize it's quite a mixed audience today. Some people are very technical, some people know a lot about what we do. Some other people will not have come across this before, so we'll try and keep it a mixture of levels. We'll then talk a bit more specifically about Apache Pulsar. And because this is a Finos partnership, we thought it'd be really good to talk about Fintech and financial services and how that can be useful. Then, as Colin said, we'll focus on why we chose a commercial open source software route as a company, because many companies go down a classic proprietary commercial route. We thought we would be different in the way that we approach it, and that has benefits and challenges, which we'll talk about. We've got some resources to share. Sadly, we couldn't get the swag here. There is some amazing swag at the table, but we do have online materials, which I'm sure you'll find very useful if you're interested and want to follow those up. Because it's quite tight on time, I'm sure you may have questions. We'd love to talk about them, but if you want to either submit your questions online or hold on to them to the Q&A at the end, and then we'll rattle through as much as possible. We'll be here all evening, so happy to talk after our chat as well, if that's okay. So, Tim, over to you.
Okay, so what are we talking about when we're talking about Pulsar? One major component is messaging, and that means a lot of different things. A lot of them are listed here. A common thing is you want to have an event comes into your system. It could be a transaction. It could be a log, database entry, lots of different things. They happen asynchronously everywhere, and these just get triggered into some messaging system. You want to be able to consume those messages with whatever code you have, whatever system. You don't want to be tied to one language or one protocol. So that's a common use of messaging. You have more messages than you can handle, so they have to queue up. They need to go somewhere special. You know, a message comes in, we need to send it to the right place at the right time. You might just want to be able to stack up events, applications, or triggers so you can work on things. That's a work queue. And then JP Morgan Chase had developed AMQP as a great way to do high-speed financial messaging, and we support that within Pulsar as well. Data streaming is a little different from messaging. There's a lot of semantics there, and some people will use them interchangeably, but there is some differences. Ideally, they're used to do real-time processing or whatever means real time in a business sense. In financial, sometimes we're talking, if someone moves a radar dish, it's no longer real time. A little more in the sub-second than the sub-millisecond here. Event happens, we process it. I want to be able to take different streams of data, put them together, do with something like SQL, which most people know. Try to find anomalies in data event streams as they happen. A log comes in, a mobile app produces some data. I want to know right away someone's card is stolen, something unusual is happening. I don't want to wait a minute. I don't want to wait at the end of the day, wait for a batch. As something happens, I want to be able to know right away, maybe apply machine learning. I may have very specific ordering constraints. Things have to arrive in the order they were created or based on some kind of time stamp, or they may have to exactly arrive. If I put in 5 messages, I better get those 5. And it's just going constantly. It's not something I could start, stop. It just keeps going. Data just keeps flowing through the system. When might I do one or the other? Depends. If you need to do historical and real-time data, that's usually streaming. Pub sub model, you can have event streams from a lot of different things, because you may have, it maybe the data is coming from every server you have. Could be 1,000. Could come from every mobile device, every app you have on a desktop. Lots of different people producing data. Lots of people consuming it to use it, and have them be distinct and asynchronous from each other, so there's nothing tying you to one or the other. And you want to be able to produce and process lots of data. I mean, we're talking petabytes of data, could be millions of messages, and you want to do that and be able to scale up and down without any kind of difficulties or issues, or having to build out new servers every time someone adds another million transactions. There's a number of places in the industry where we see this happening more apparently than others. Certainly today, everybody is being affected by more data, whether it's from logs, sensors, just everything produces a lot of data now. But these 3 areas have been key in what we see where people really need something like Pulsar, banking, because you're starting to get all these different systems that have built up over decades, maybe from mergers, maybe from moving some apps to the cloud, some to different data centers. So you got to combine all those different streams of data, and they might be in different protocols, all different versions, all different languages. Getting them all together in one place real time, that's a big need in banking. IoT, like I mentioned, sensors. Everybody has sensors, whether it's coming off of some little teeny device or it's coming off of 10,000 ATMs, lots of data coming in a stream, usually with timestamps on them. This is a big use case for Pulsar that we're seeing. Insurance, again, that fraud detection comes up a lot. Being able to integrate different systems and being able to just do things faster as it happens. Event happens, there's a car accident. I get that information in a system somewhere. As that's produced, I could start doing all the work that's required, make sure it gets distributed to every partner system, every data bank, every database that needs it, get it to them as fast as possible. Apache Pulsar, there are some buzzwords in there, but cloud native is the way we're designed, with a separation of compute and storage. Runs natively on Kubernetes as everything must, and it's designed to be a complete event streaming platform, not just a little piece. What's nice with Pulsar is we put those 2 big concepts together. Most people now have work queues that might be in RabbitMQ, they could be in SQS, you could be using some legacy JMS systems, you might have a bunch of different messaging systems. We could do all those type of use cases within Apache Pulsar. As well, on the other side, we could do all the streaming ones, which you might be doing with everybody's favorite Kafka or Kinesis, or maybe some proprietary similar thing or some different variation of that. And we support the native Kafka protocol if you don't want to have to rewrite any of your applications. This is my nice chart. There's a lot of things going on. Unfortunately, when you unify messaging and streaming, there's a lot of things going on. But what it comes down to is I can get a lot of different protocols in and out, which means I don't have to rewrite code. I don't have to pick one language or another. I could do Python or Java or Go or C# or C++ or Node.js, or I could just do it with WebSockets in a web page. Could do MQTT. Any of these protocols, don't have to rewrite things. Once data gets into our topics, it doesn't matter where it's going to. It's all treated the same. It can be stored forever in your infinite cloud tiered storage, and lots of different tools to work with it. We work with all the other mainstream open source projects. Lots of cool benefits besides what we mentioned before. That tiered storage, so you don't have to worry about what happens if I get 100 petabytes. I don't want to pay for expensive SSDs. Just it'll automatically go into S3 and have no difference to you on how you work with it. Very resilient because that separation of compute and storage, each layer scales out independently. Everything's asynchronous. You don't have to worry about things being too tied down if a node goes down. Easy to build real-time apps. And what's nice is built-in ability to build and support microservices, which is a nice way to build applications. You want me to do this one? You doing this one?
I thought you were doing this one, but
I can do this one. There's a lot of people using it, and they're all cool. So
yeah, we're going to individually just walk through each and every one of them. No, we're not. So yeah, so thanks, Tim. So when we look at the features and benefits of Pulsar, what we find is that they're a really good match for financial services, fintech applications. So if we hone in on a few of these areas, so the need for large data volumes, if you think about transactions, financial transactions flowing between different components within your system, you need high scalability, which Pulsar provides. Also, the event messaging capability, where you have topics, we have producers and consumers of data. We appreciate we've not got into a deep dive of this architecture, but fundamentally this allows a very distributed system to be easily developed and have the information that you need reliably be sent to the different components within your application. Financial services is also very demanding as an application space, particularly around the need for low latency. Obviously, if you've got financial transactions, that's something that requires a very short timescale for delivery of the messages. You need geo-replication, so you have high availability, resilience of your data. So Pulsar naturally supports multiple zones, multiple availability zones, multiple regions, multi-cloud strategy. Your data integrity, when you're sending information as messages, you need to make sure that they arrive in order, and if you need them to be processed exactly once, that's guaranteed by the platform. And durability, as Tim was talking about, the way in which storage is just seamlessly managed by Pulsar means as a developer and an architect, you don't need to worry about how that's going to be managed. It's just there when you need it. And of course, for financial services applications, that's essential. And lastly, multi-tenancy. Often, in financial services applications, you may have a complex data model that requires different customers to have access to different parts of data, or role-based access control, or row-level security, or different ways in which you partition the information. And again, that's part of the features and benefits of Pulsar. So put all that together, the kind of applications that are commonly seen in financial services, you will have multiple consumers of your data, so your transaction information. You may have payment processing that flows through to different parts of your system. You may need alerts. You may have analytics. You may want to be able to just build onto your system ways in which you can examine what's happening. And KYC, know your customer, in this increasingly broken and fragmented world we sadly live in, there's more and more regulations, compliance checks, restrictions being applied that need to be built into a system that's handling financial transactions. And lastly, fraud detection, analytics, machine learning and AI. Again, you can design your application so that just the parts of the information you need get sent out to the consumers of that data. I would like to talk about some of the banks that are using Pulsar today, but I can't name them because we're under non-disclosure agreements with them. But they are a growing number of banks, financial services, insurance sector companies, insurtech and fintechs, using Pulsar as the fabric for these reasons we've just been discussing. So that was a technical side. So if you weren't enjoying that technical part, you can breathe a sigh of relief. We're going to talk now about why open source and why we chose that route as a commercial company. So to answer that question, we need to go back to the heady days of the mid-teens, pre-COVID, which feels like a lifetime ago. So our founders, CJ, Matteo, Ja, they were previously working at Twitter and at Yahoo, and they were running some of the biggest Apache Pulsar and Apache Bookkeeper clusters at the organization. And they created this framework. And they realized that in order for this to really survive, it would benefit from being released into the open source community. And at that time, Yahoo was famously releasing a lot of components through to the Apache Software Foundation. It was a natural choice for the software framework at that time. So that required a bit of a leap of faith. They had to place some bets and make some decisions that would be the basis of the company going forward. And they assumed that they would get some benefits from an open source model, some of the things that we've been talking about. So not least, they were hoping that other companies, individuals would contribute to development of the code base. I'm pleased to say we have over 500 active contributors to Apache Pulsar currently. Also, you get the benefits of security. Many developers reviewing, analyzing, improving the code. You're not limited by who works for your company. Code escrow. If StreamNative as the creators or Yahoo then, if we went out of business, suddenly not available, if companies are using Pulsar, they still have access to the source code. And that gives longevity. So for this system which they had developed, that was very appealing. Also, the founders strongly believed in the importance of keeping the core features within the open source free version. So you may see some open source frameworks where there's a core which has most but not all of the features you need. But with Pulsar, right from the beginning, we were clear that we wanted to keep everything in the free version. But that meant that in order for it to be viable as a business, we had to find commercial offerings around that, which would be a services-based model initially. So I'll talk about that next. So as a commercial open source software company, as opposed to free and open source software, there are a number of benefits and challenges. So the benefits we've just been talking about of having many developers contributing to the code base, that's certainly been the case. So I'm speaking now as obviously someone who's newer to StreamNative, and I'm seeing that in terms of how our product is evolving. We also have had the benefits of security, longevity, escrow. That is something which is quite reassuring for our customers, that they know if they choose to use Apache Pulsar, that they get these benefits. The challenges, and so this is where I put my coin-operated salesperson hat on, is very much, well, if it's free, why and how would you get people to pay for it? It's free software. And there's been a number of reasons why they have done that. And essentially, the benefit has been that we offer peace of mind, because the solutions that we are selling, that people buy from us, pay for, are the commercial hosting. So whether it's a managed service on their cloud or our cloud, whether we're providing consultancy services, helping answer questions, they know that if they come to us, they're going to be able to deploy, manage, run complex Apache Pulsar clusters, base their business on it, and it'll be a reliable service. And as the creators of Apache Pulsar, who better to come to than StreamNative? The other aspect why people may pay is that sometimes free is perceived as low value or no value, which is a curious one. But for larger organizations, if they're going to make a decision to use it as their foundation, this really matters. And so they want to know that there's a commercial relationship, a procurement team, a legal team, service level agreements, all of that support. That does factor around the way in which we sell our services. Another challenge has been managing multiple roadmaps. So most commercial companies with closed source proprietary products, you have your own product roadmap where you've just got to think about the competing needs of your customers, or what you might do in the future, or what's going to bring in revenue sooner. That's normal. But for us, we are managing remotely. Oh, I should clarify that we don't own a StreamNative. We don't own the Apache Pulsar code base. The PMC, the Project Management Committee within the Apache Software Foundations, they own it. So we contribute along with other people to what happens with that software stack. So that means for us, we are thinking about, if we're going to enhance it, do we go through the open source route, or would it be something which we may want to build some commercial tooling around our products in the services space? So that adds a little bit of complexity to our offering. So I'll hand back to Tim. I think we can talk about resources and come on to some questions, but Tim.
Sure. Yeah, I mean, we have a lot of cool stuff available, and as an open source company, we make as much of it free and easy to use. The Academy is free training that lets you spin up a free Dockerized environment to try out Pulsar with a bunch of different languages, whether it's Java, Python, Go, and some other ones. And also we've got a number of videos to walk you through the basics of, what we didn't get to do in a couple of minutes here. You could see a full hour, or look through all our other videos where you could see different companies talking about, what they've done with Pulsar. And we got an awesome free book. My colleague David wrote this. He's been involved in the Pulsar community for a number of years. This is a very full book. You get the full PDF of the book. It is a very in-depth book. If you go through this whole thing, you will be an expert and ready to do whatever you need to do in Pulsar. Nice book to have. And we are definitely open for discussing anything about Pulsar. You can hit me at any of these links. GitHub's always a good place. I have a lot of code there for people to check out, examples, demos, those sort of things.
Fantastic. Thanks, Tim. And thank you, everyone. I think we just did it in 20 minutes, so that was remarkable. It worked.
Great job, yeah. Thank you very much. Yeah, that'd be great. Any questions? Oh, Andrew. I could have guessed it would be Andrew. Go on. What's your question?
So, obviously, it's different than Kafka. Could you give is there one selling point, one thing where you go, think about this is different for Kafka than does?
Yeah. Can I just reiterate? I know the people listening online probably can't hear that. So the question is, I know it's different from Kafka, but what's the kind of pithy single sentence that differentiates?
So I'm going to refer to Tim on this because when we were preparing our Q&A, so what's going to come up? And my first question, I thought, someone's going to ask, what's the difference between Pulsar and Kafka? So if this was QI, you would get the klaxon now, Andrew, with asking that question. So Tim, did you have that was one for you, wasn't it?
You put it in one sentence. I mean, I think the difference is, especially for the Kubernetes people, for one sentence, is cloud native architecture. So we have compute and storage separate. That alone is enough. But the built-in tiered storage, the support for other protocols, the built-in open source geo-replication, it just features that you expect to have in someone who saw what happened before in Kafka and needed some other things, like support for AMQP, support for MQTT, support for RocketMQ, support for the Kafka protocols natively. So you can do whatever you did in Kafka, plus more with a cleaner design.
That was slightly more than one sentence, but I think it was a good answer. Any other questions at the back? I think the question was, how resource intensive is it to use a cluster with Apache Pulsar? How much does it cost? Yeah.
And so, Tim, the question there was how much does it cost, and also the overall kind of complexity footprint, I guess. We should definitely talk after this session to go into. We're delighted to talk about the money. I mean, the kind of the short answer is this is obviously complex. If you look at the way in which cloud software systems, if you go to AWS and try and figure out how AWS charges for its software elements, I'm sure, like all of us, we were scratching our heads thinking, gosh, that's quite difficult looking at, compute and ingress and egress and charges and availability zones. So we try to be simple with that. And like I said, and I'm trying to be careful to separate, what StreamNative does is offer that cloud hosting, cloud managed service, and we support. But ultimately, if you want to use Apache Pulsar and focusing on the open source aspect of it, you're free to do that at no charge whatsoever. And then, of course, it's a scaling question, sizing question about how to configure and dimension your system. And if you need help with that, then sure, we can help with that. And what we find is that, like I said earlier, people come to us for peace of mind in that we can just manage it for them. So that's the kind of very small plug for StreamNative. But the Apache Pulsar framework itself is brilliant. And I would encourage anyone who's curious about it to try it, and we can provide free trials or just give it a go. I think Paul's got a question.
I think what we'll do is leave that for a question from Discord. Oh, fantastic! Oh, yay!
What are they looking for from the community in terms of contributions to the source code?
Yeah, sorry. Oh, it's on my one as well. Bit of a lag. Yeah. What are you looking for from the community in terms of contributions to the source code?
Tim, do you want to take that? Because this is, I think, a really good
question. Yeah, this is a better one for me. I mean, we have a lot of committers, but everyone needs more. we're especially looking for people who want to look at some of the old requests people have out there. And for people who aren't coding, who want to help, there's always need for documentation, demos, articles, people testing things, looking at the latest versions. If you use an exotic language or are looking for a connector, we can always use more connectors written. If you see something that's not there, we are very happy to have someone put in the code for a new connector. Maybe you have a different database you're using we don't have yet. Maybe you just want to look for bugs. Maybe you have some things you want to add to the C# client. Whatever you're doing, there's probably some way you can help. I mean, always looking for help. It's a pretty nice geographically spread out community. Just contact me if you have any specific skills or interest, and we could try to match you up in the right place. We have a pretty good Slack channel for that.
Cool, thanks very much. And it was interesting there, a reference to non-code contributions, which after the break, we'll be having a couple of talks about the non-code side of open source. So once again, thanks to you both. Excellent talk.